Hello, my dear students. I, Dr. Mala Das Sharma, welcome you to the video number 7 of Inorganic Semi-Micro Analysis. In this video, I am going to discuss the confirmatory test for the volatile group A acid radicals. And in my earlier video, you have seen that under this volatile group A, the acid radicals which are present are carbonate, sulfite, nitrite, thiosulfate and acetate. In this video, I am going to discuss the confirmatory test of carbonate, sulfite and sulfide. So, let's start. So, the confirmatory test. First thing is the preparation of the solution. In the dry test, we just take the dry salt or salt mixture, there we add the reagent. But wet test or confirmatory test, we prepare the solution. And the solution we prepare either in water, in case of acid radical, or we prepare the sodium carbonate extract. So in the solution, these anions, that means acid radical, goes to the solution state. And this is known as the original solution. So first let us discuss for the water extract. So you have to take the salt and salt mixture in a beaker. You add water, you boil it for 10 to 15 minutes and then just cool it and then centrifuge and then reject that residue part and that filtrate or centrifugate, that is your water extract. From the water extract generally used for the detection of nitrite, nitrate, acetate and thiosulfate. Now coming to the sodium carbonate extract. This preparation of sodium carbonate extract I am going to tell in the next slide. Remember, sodium carbonate extract we prepare to take the ions or acid radicals or anion to the solution state for doing the confirmatory test. Okay. So, if your salt or salt mixture is completely soluble in water, then you can prepare the solution in water only, that is aqueous solution. In that case, no need to prepare the sodium carbonate extract. Another thing is that from the dry test, if you get the indication that your salt or salt mixture may contain carbonate or bicarbonate, in that case also you need not prepare the sodium carbonate extract. Okay. Now, preparation of sodium carbonate extract. In the preparation of sodium carbonate extract, what we do, we just take this salt mixture, okay, salt or salt mixture in a beaker. So in a beaker, you are taking the salt or the salt mixture, okay. Then you add 3 times, how much amount of the salt mixture you have taken, 3 times of it sodium carbonate, solid sodium carbonate. So 1, 2, 3. 3 times of solid sodium carbonate you add it and then you add water. Then boil it for 10 to 15 to 20 minutes. Okay. Then cool it and then centrifuge. And then your centrifugate is the sodium carbonate extract. Okay. So, when you are preparing this sodium carbonate extract, this type of double decomposition reaction takes place. So, this is the salt. Here I have taken the monovalent metal ion and this is the anionic part. When you are treating with sodium carbonate, double decomposition means that exchange of ions will take place and your metal ion will be deposited or comes out at the residue of the carbonate. Okay. So metal ion will come out as carbonate in the form of residue and your anion will convert it to sodium salt. Anion will combine with the sodium and it will form the sodium salt of the anion. And we know that sodium, potassium, ammonium salts are soluble in water. So it will go to the solution, right? That means filtrate, in the filtrate, you will have the anions in the solution, right? And that is your sodium carbonate extract. Now remember, when you are doing the test with sodium carbonate extract, first you have to neutralize with the acid, either hydrochloric, nitric, sulfuric or acetic, depending on the acid radicals. Because sodium carbonate means it is alkali. So your solution will become alkaline. So first you have to neutralize it before performing the test. Now coming to the confirmatory test for carbonate and bicarbonate. You warm the salt mixture with distilled water and centrifuge. Okay. Then what you will get? The residue. The residue, if you get the residue, if your salt is completely soluble in water, then you will not get the residue. If your salt is insoluble, you will get the residue. If your salt or salt mixture is partially soluble, say one salt mixture, one salt is soluble, one salt is insoluble. Okay, then you will get the residue, and in the filtrate also some anion will be there. Okay, so in the residue, you add dilute hydrochloric acid. If you get Briggs effervescence and the gas turns lime water milky, then it confirms the insoluble carbonate because it has come to the residue, not soluble in water, insoluble carbonate. Now, coming to the centrifugate. The centrifugate, if you have soluble carbonate or bicarbonate, that will go to the water solution. That means in the centrifugate. So centrifugate, it may contain soluble carbonate or bicarbonate. You divide it into three parts. So in the first part, you add the dilute hydrochloric acid. Once again, the same thing, Briggs effervescence. That indicates bicarbonate or soluble carbonate. Next, to another part, you add barium chloride solution. White precipitate, if you get, that is soluble, white precipitate, and that is soluble in dilute hydrochloric acid. That indicates the soluble carbonate present in your salt. Then to another part, first you add magnesium sulfate. If you get white precipitate immediately, that indicates carbonate, that is soluble carbonate. But if you get the white precipitate after boiling, that indicates bicarbonate. So by this test, we can differentiate between carbonate and bicarbonate. Now coming to the reaction and the chemistry behind this reaction. So what we have seen, that the residue, you have to add hydrochloric acid, the Briggs effervescence, like this. If you get the Briggs effervescence, that means what is the reaction? Say you have the carbonate salt in the residue, that is insoluble carbonate. So I am taking sodium carbonate, plus you have what you are adding, hydrochloric acid, but it is insoluble carbonate. Okay, but for showing the reaction, I have taken sodium carbonate. So it is your, what it will be, sodium chloride plus carbon dioxide plus water. Okay, next, this gas, that means carbon dioxide gas, it turns lime water milky. So if you pass this gas to lime water, then it will become milky. Turbidity will appear. So what is lime water? Calcium hydroxide plus carbon dioxide. It will form this calcium carbonate. The turbidity is due to this calcium carbonate plus your water. Okay. Now if you pass more carbon dioxide to that solution, then what will happen? This solution will become clear. Why? Because now this calcium carbonate plus more of carbon dioxide you are passing, then it will form this calcium bicarbonate, which is soluble. So the solution will become clear. Now coming to the next test, to the water extract, add barium chloride solution, white precipitate, soluble in dilute hydrochloric acid, that is soluble carbonate indicates. So same thing, you are taking this water extract, say I am taking the sodium carbonate salt plus your hydrochloric acid, same way sodium chloride plus, sorry, not hydrochloric acid, I wrote wrong here. It is your sodium carbonate plus barium chloride solution. Okay, what will form? It will form this barium carbonate plus sodium chloride. White precipitate soluble in dilute hydrochloric acid. So this barium carbonate plus hydrochloric acid, once again what will form? This barium chloride plus your carbon dioxide plus water. So barium carbonate precipitate is formed. Once again you are dissolving the precipitate. Once again barium chloride comes and carbon dioxide and water. Now here, third test, to the water extract add few drops of magnesium sulfate solution. If the soluble carbonate is there, then what will happen? Say soluble carbonate I am taking, say sodium carbonate plus your magnesium sulfate. Okay, so immediately you'll get the white precipitate of magnesium carbonate. This is white precipitate. These are all double decomposition reaction. So it will be, another part will be sodium sulfate, right? But if bicarbonate ion is there, then magnesium bicarbonate will form. But magnesium bicarbonate is soluble in water. It will remain in the solution state. Okay. So if you take the bicarbonate NaHCO3 plus magnesium sulfate, say if the bicarbonate is present, then you will get magnesium bicarbonate plus as usual sodium sulfate, right? But it is soluble. Now if you heat this magnesium bicarbonate, then what happens? It will decompose and it forms the precipitate of white precipitate of magnesium carbonate, right? And then plus carbon dioxide plus water. So then you will get the white precipitate. So therefore, if bicarbonate is there, immediately not get the precipitate. Okay. After boiling, you will get the precipitate. And immediately if you get the precipitate, that is soluble carbonate. So by this test, we can differentiate between carbonate and bicarbonate. Now coming to the confirmatory test for sulfite. What you have to do? You have to take 2 drops of sodium carbonate extract. Then you add acetic acid, boil off. That means you have boil off carbon dioxide. So it will become neutralized. Now add barium chloride solution and centrifuge. You will get the white precipitate. Okay. Now to one part of the precipitate, add hydrochloric acid. If the precipitate dissolve, then it is sulfite. Okay. Another part, you add potassium permanganate and few drops of sulfuric acid. The pink color discharge, that indicates the sulfite. Then you take the sodium carbonate extract and then you add few drops of potassium dichromate and 2-3 drops of sulfuric acid. If the green coloration, if you get the green color, that indicates the sulfite. Another test, you take the few drops of sodium carbonate extract, then 1 drop of 1% sodium nitroprusside solution and 1 drop of zinc sulfate solution, formation of red rose color that indicates sulfides. Now let's see the reaction and chemistry. So 2 drops of sodium carbonate extract plus acetic acid, boil of carbon dioxide, then you are adding the barium chloride solution, the white precipitate you are getting, right? So you are adding this after neutralizing the sodium carbonate extract, you are adding this barium chloride and you get this precipitate. Then what is this reaction? You have the sulfide. So I am taking the sodium sulfide, Na2SO3, plus you are adding barium chloride. Then once again this double decomposition reaction. So it will be barium sulfide. This is your white precipitate, right? And then what will form? Sodium chloride plus sodium chloride. Right? You will get this white precipitate. Then to one part of this precipitate, add dilute hydrochloric acid. So when you are adding dilute hydrochloric acid, precipitate dissolve. So precipitate dissolve. What happened? Now, once again, precipitate was barium sulfide plus you have added hydrochloric acid. Then what will form? It will form once again the same barium chloride will form. It will go to the solution plus sulfurous acid, that means sulfur dioxide plus water. It is the same reaction, that is strong acid can release the weak acid from the salt. That means sulfurous acid is released, so sulfur dioxide and water, which will come out as sulfur dioxide and water. Okay. Now, to another part, add 1-2 drops of potassium permanganate solution and 2-3 drops of dilute sulfuric acid. The pink color of the potassium permanganate discharge. Then also sulfite confirmed. So when you are adding this potassium permanganate, the pink color immediately discharge. Then what is happening here? Here you have, say, sodium sulfite I am taking, sulfite plus potassium permanganate plus sulfuric acid. It is a redox reaction. Sulfite means sulfurous acid, salt of sulfurous acid, so which is a reducing agent. It will reduce this manganese, here it is in the +7 state, to manganese +2. Okay, so the product will be, here it is, sodium sulfate plus potassium sulfate plus manganese sulfate plus water. Now here this manganese is in +2 state. So sulfurous acid, that means anhydride sulfur dioxide, what it does, it reduces manganese +7 to +2 state and itself converted to sulfuric, that means sulfate ion. So remaining all form the sodium sulfate, potassium sulfate, manganese sulfate, like that. Okay, so sulfurous is converted to sulfuric and manganese +7 reduced to manganese +2. Now, next one, what is that? Sodium carbonate extract. Then you add few drops of potassium dichromate solution and then 2-3 drops of sulfuric acid. Green color you will get it like this. When you are adding potassium dichromate to this sodium carbonate extract, and then it will become green. This is also redox reaction, similar type. So sodium sulfide plus your potassium dichromate plus sulfuric acid. What will happen? Here chromium is in +6 state. It will be reduced by sulfurous acid or sulfur dioxide from sulfide. 2 chromium plus 3 state. So Cr2SO4 whole 3. Here it is in plus 3 state. And similarly, sulfurous will be converted to sulfuric acid. So all will be in the form of sulfate. So it will be sodium sulfate plus potassium sulfate plus water. Okay. Now the next is 3 drops of sodium carbonate extract plus 1 drop of 1% sodium nitroprusside solution plus 1 drop of zinc sulfate. You'll get the rose red color. What is this reaction? This sodium sulfide, I'm taking sodium sulfide plus your sodium nitroprusside. What is that? Na2FeCN5 then NO. Okay, and in presence of zinc sulfate, then the complex is formed. What is that complex? Na4 here, Fe, then CN5, NO, and SO3. So this complex, this whose color is red rose color, red rose color. Okay. So these are the test, confirmatory test for sulfide. Now remember one thing. When I discuss about the analysis of after completing anions and cations, when I discuss the analysis of the salt mixture, then you will find that in the dry test, when you are getting the indication of the ion, say you are getting the indication of carbonate or sulfide, then only you should do that confirmatory test for that particular anion. Okay. Now coming to the test for sulfide. Okay. What is the first test? 2-3 drops of sodium carbonate extract and 1 or 2 drops of sodium nitroprusside solution, a violet color that indicates the sulfide. See, when you are adding sodium nitroprusside, you will get this violet color. Now, what is this reaction? Here also, I am writing here. See here, your sodium sulfide plus sodium nitroprusside solution, same thing, Na2FeCN5NO, and then you'll get the complex. What is that complex? Na4, then FeCN5NOS. And color of this complex is violet color, right? Now coming to the second test. Second test, what is that? Sodium carbonate extract, 1-2 drop of cadmium carbonate suspension in water. Then you'll get the yellow precipitate, right? So here also what you have to do? You take this sulfite salt plus cadmium carbonate suspension in water. So this is cadmium carbonate. Then here also double decomposition reaction. What it will form? It will form this cadmium sulfide. This is yellow precipitate plus sodium carbonate. This is yellow. Right? Now, what is the last test? Acidify 2-3 drops of sodium carbonate extract to dilute acetic acid, boil off carbon dioxide, then 2-3 drops of lead acetate solution, black precipitate. So, if you add, after neutralizing the sodium carbonate extract, if you add the lead acetate solution, then this black precipitate will form. What is the reaction? Similar type of double decomposition reaction. Here I am taking the sodium sulfide plus here lead acetate CH3CO whole 2 Pb. Okay. So here double decomposition reaction means the ions will change, exchange of cations and anions. So this lead sulfide will form lead sulfide, which is black precipitate, and remaining it will be the sodium acetate, CH3CONA. So these are the confirmatory test for sulfide. Okay. In the next video, I'll discuss the confirmatory test for other volatile acid group A radicals. Okay. Hope you have understood. Thank you.